of Illinois, where he's an assistant director for the Scientific Software and Application of the National Center for Supercomputing Applications. He's also a research associate in the computer science, electrical and computer engineering, the School of Informatics Sciences there at the university. Dan's research interests include policy issues such as citation and the credit mechanisms and practices associated with the software and data, organization community practice for collaboration, career paths for computing researchers. He is one of the recipients of the 2018 Better Scientific Software Fellowships Program, which gives recognition and funding to leaders in the field and also advocates the high-quality scientific software. My understanding is that he's going to have a slide on that program. So then with that, please, take the stage. Thank you.
Okay, thank you. Take me a minute to transfer everything over. All right. So yes, I'm Dan Katz. I'm going to talk about software citation and where things are today. And in order to start that, I want to talk about the role of software in research. My claim is that software, including services, are essential for the bulk of research today. And we have evidence from this in two different areas. We have evidence from surveys. There was a study done of UK academics at Russell Group universities, which basically is the leading research universities in the UK, in 2014. There's two footnotes at the bottom that show where this information is and where the data is. I should say at this point that these slides will be available, and so anybody that's interested can find any of the backup for any of the material that I'm saying. In addition, we studied members of the U.S. National Postdoctoral Research Association last year. And in these two groups, we asked people to pick one of three options. One option was to say, my research would not be possible without software, which was about 2/3 of the participants in both groups. The second option was to say, my research would be possible, but would be harder. And that was about 1/4 in both groups. And the final option was to say it wouldn't make any difference. And that was a relatively small percentage. So this is basically the first thing that we want to use to say that that software is important to research today. The second thing is to look at services, and we want to look at papers, at scholarship, and to look specifically at journals. About 3 or 5 years ago, I informally looked through a number of issues of Science, discovered that about half of the papers were software intensive, and of those that were not, most of them certainly included some software in them as well. We did a slightly more formal study last year, and we looked at issues of Nature from January to March of 2017, and we discovered that software was mentioned in 32 of the 40 research articles, and an average of 6.5 software packages were mentioned per article. Sorry, I don't actually have this on the slide, but I should say that James Howison from the University of Texas is pursuing this in a much more rigorous way and across many more articles, but his initial data looks roughly similar to this. If we think about where software fits into the research cycle, and the research cycle I'm going to use here is kind of it's kind of what you might imagine somebody in middle school thinks is how science is done, which isn't exactly right, but is close enough. We initially create a hypothesis. The person that does that then tries to acquire some resources, some funding, some software, some data, some things that they're going to be able to use to study that hypothesis, to prove it or disprove it. They actually then perform some research, and in that process, they may build some new software. They may take their data and analyze it and create some output data. They then want to publish the results of what they found, and they could publish those previously in the form of a paper or a book, but possibly today in the form actually of software that implements a method or the data that actually demonstrates something. And this is where the knowledge is. And having done this, then they want to complete the cycle and to use this knowledge to have some further hypothesis. In order to do that, they may need to gain recognition from what they've done. And when we look at software here, we see software showing up in two different ways. One is that software is part of the research process itself, and the second is that software is part of the infrastructure. And this infrastructure software, the thing that comes into the process, the thing that goes out of the process, this is what ideally is going to be shared and what is going to be cited. And that's what I'm mostly going to focus on through the rest of this talk, because this is the thing that somebody wants to get credit for as well. So the motivation for software citation is that, as I've said, scientific research is becoming more open. Scientists want to collaborate more and they want and need to share. And it's becoming more digital, where outputs are software or data, and those then are easier to share. There's significant time spent developing software and data. Sorry, give me 1 second. Okay, and the efforts in doing this are not recognized or rewarded traditionally. We have a system that collects citations for papers, and it does it systematically, and there are metrics that are built, and there's an entire infrastructure that works for this. But we don't have anything similar for software and for data. And so I hypothesized, actually this is probably 4 or 5 years ago now, that if we had a way of better measuring contributions, such as citations, such as the impact of software, such as metrics that, studied where software was being used, that would lead to better rewards, better incentives for people actually contributing. This would lead to better career paths for people who develop software, and would increase their willingness to join communities and to spend time doing this, and would in the end then lead to more sustainable software. So if we want to better measure software contributions, we have, as I said, the fact that we have a citation system that was created for papers and for books. And so we have to do one of two things. One of them is to jam software into the current citation system, and the second is to rework the citation system entirely. We're focusing on the first one because the second one, while it's probably the right thing to do in the long run, is something that's very hard and will take a much longer period of time, and we'd like to do something that actually has an impact sooner rather than later. The challenge overall that we're trying to address is not how to identify software in a paper, but how to identify software in a research process overall. So today, if we look at software citation, we find that software and other digital resources appear in publications in very inconsistent ways. James Howison did a study of 90 articles in the biology literature in 2015 and found 7 different ways that software was mentioned, from citing the publication about the software, a paper about the software, to citing the user's manual for the software, to citing the name or the website of the software, to treating the software like it was an instrument, to including the URL of the software in the text but not having a citation, to having the name of the software in the text but not having a citation, to not even having the name. And when I saw this last one, I asked James what not even the name meant, and his description basically was that the paper says something like, we used software written in Java to do this. But that's it. It just says that there was software, but doesn't say anything more than that. People have done studies also on data and on facility citation and have found similar results. These also are under-cited, and when they are cited, they're cited very inconsistently. So in order to address this, in July of 2015, a group started called the Force 11 Software Citation Group. Force 11 stands for the Future of Research Communication E-Scholarship, and 11 is that it started in 2011. In a little bit later in that year, in 2015, there was a group called WSPE 3 Credit and Citation Working Group that joined the Force 11 group. WSPE is working towards sustainable software for science, practice, and experience. This was the 3rd meeting. And WSPE had a number of working groups that formed over a 3-day period, some of which went off and did things, some of which completed things. And this one decided that it would work together with the Force 11 group. So this led to a total then of about 55 members, researchers, developers, publishers, repository people who were part of this working group. We did all of our work on GitHub. And also had a page on the Force 11 website that pointed to what we were doing on GitHub and had some slightly easier ways of seeing for people who are familiar with GitHub. We reviewed existing community practices and developed a set of use cases for software citation. And then we drafted a software citation principles document. And we started with a data citation principles document that had come out a year or two earlier and updated it based on the software use cases and related work. Then updated that based on working group discussions that we had and community feedback and review of an early draft. And then we had a half-day workshop at the Force 2016 conference in 2016. And most of what we did was discussed through GitHub issues with changes tracked in the document. We also used Hypothesis at some point to let people have a different way of annotating a draft. And we have this paper then that came out of this. It contains 6 principles and discussion and use cases, and I will talk about those in slides as we continue onward. The paper itself then was submitted and reviewed and modified a bunch of times, and then finally published, as you see here, in PureView Computer Science. And one of the interesting things with PureView Computer Science is that we were asked when this was finally accepted, would you like to also include the reviews and your responses? And we said yes. So you can see, again, the whole process from the initial work in GitHub to the final work in the publication process. And our intent is to make this whole effort as transparent as possible, because we want this to be something where members of the larger community that uses and develops software sees this and sees the value in it. So before I go on and actually get into the details of this, I want to just stop at this point and see if there are any questions briefly.
Hey, Dan, I don't think we've gotten any thus far. Thank you for stopping, though.
Okay, I will continue. I'm also kind of keeping an eye on the chat, so if things come in, hopefully I'll see them there as well. Okay, so the first of the 6 principles is important. It says that software should be considered a legitimate and citable product of research, accorded the same importance as citations of other research products. These principles are in some cases long, in some cases short. I'm just going to read the part of it that I think is really the kind of the essential part. But the full principles are on the slides and in the paper. The second principle is credit and attribution, which says that software citation should facilitate giving credit and attribution to all contributors. The third principle is unique identification, which says that a software citation should include a method for identification that is machine actionable, globally unique, interoperable, and recognized. The fourth principle is persistence, which says that unique identifiers and the metadata that describes the software and its disposition should persist. The fifth principle is accessibility, saying that software citation should facilitate access to the software itself and to the associated materials necessary to make informed use of the reference software. And the sixth principle is specificity, that software citation should facilitate identification of and access to the specific version of the software that was used. So we believe that these 6 principles are very high level and are very general and should be applicable in almost every situation. Exactly how and what the situations are and a number of things related to that we thought did not rise to the level of principles, but also were important to talk about in the paper, and we call those discussion topics. And I'm going to go through some of those discussion topics next. And then after that, I'll pause and see if there are more comments. So one question is what to cite. And the importance principle says that authors should cite the appropriate set of software products just as they cite the appropriate set of papers, which basically means that which software should be cited is decided by the authors of the products that would be doing the citing in the context of the community norms and practices of that research area. One thing that's worth pointing out is the Purdue Online Writing Laboratory says, do not cite standard office software such as Word, Excel, or programming languages. Provide references only for specialized software. And the way that we took this and what we put in the discussion as a recommendation is that if using different software would produce different data or different results, then the software used should be cited. And if the software is a kind of a shorthand that is used but is not really important in the result, then maybe it doesn't need to be cited. But again, the community should really be deciding this. The author should be saying what they think needs to be cited. The reviewers and the larger community should say yes or no. All right, this doesn't need to be cited. Something else can be added, something like that. Second discussion topic is what to cite. There are provenance and reproducibility requirements for work that involves software that are greater than the requirements just from citation. Citation is basically a list of the software that's important to the research outcome. Provenance is all the steps, including the software, that are in the research. And the software citation principles cover the minimal needs for software citation for the purpose of software identification, where provenance and reproducibility may need more metadata than is just what's needed for identification. And I'll talk about this more as we go on. This becomes a little bit more interesting issue. Another topic is software papers. Our goal is that software should be cited, but the practice today is often that papers about software, which we call software papers, are the things that are published and cited. The importance principle and other discussion says that the software itself should be cited on the same basis as any other research product. Authors should cite the appropriate set of software products. And so what we say in our discussion section is that it's okay to cite software papers too, and particularly if they contain results like performance or validation that are important to the work. And if the software authors ask the users to cite the software paper, they certainly can do so, but they should think about this in addition to citing the software. The primary goal is to cite the software itself. Derived software is a topic that came up a lot in our discussions, and so if we imagine that we have a code A that's derived from code B, and a paper is using and citing code A, the question that often came up is, should the paper also cite code B? Because the people that built code B did a lot of the initial work. Code A authors did something with that, and now they're the ones that are getting the credit in the paper. Our answer is no, that any research is building on other research. And the way our system works today is that each research product only cites the things that it directly builds on. And those things that it directly builds on then in turn should be citing the things that they directly build on. And if we put those together, this gives us credit and knowledge chains. And we have science historians and other people that study these chains and then try to understand, in this case, what is the impact of code B on this paper. We could also do more automated analyses that may develop over time, such as one that I've talked about in the past called transitive credit, but I'll leave that for the minute. Another question then that comes up is, what about software peer review? Right? If we publish papers, we cite papers, we peer review them, should we be peer reviewing software? And we think that this is a really important issue for software and science and in research overall, but it's probably out of scope for the citation discussion. The intent of software citation is to identify the software that has been used in a scholarly product. And whether that software has been peer reviewed is not relevant to whether it's been used. A possible exception where the peer review status might be important is if that is part of the software metadata. Overall, we believe that that's not part of the minimal metadata that's needed to identify software. And for that reason, we do not believe that this is important in this context. Another discussion is the citations in the text of a paper. Each publisher or publication has its own style, right? AMS, APA, Chicago, MLA, IEEE, ACM, or a variety of different styles. There are examples for citing software that have been described in some of these styles that were published by Lipson in 2011. The citations that are sent to the publisher are generally text that's formatted in a particular citation style, not as structured metadata, which is actually a little bit weird and probably is something else that needs to change over time. Our recommendation, though, at this point is that the text citation style should support, first, a label that indicates that something is software, and that could be something like computer program or computer code or software in square brackets. And then second, that it is important to support the version information and to have something like version 1.8.7 that is part of the text that is in the list of references at the end of a paper. Since we're talking about the text and these references, then we also have the question of citation limits. The software citation principles likely are going to lead to more software citations in scholarly products. That will lead to more overall citations. Some journals have strict limits on the number of citations or the number of pages, which often includes references. And so our recommendations to publishers are to add specific instructions regarding software citation to the author guidelines that don't disincentivize software citation, and not to include references in the content that's counted against page limits. So again, these are recommendations. I'll talk about how we try to move these recommendations forward in the next section of this talk. Another topic is unique identification. We recommend DOIs for identification of published software. An identifier, however, can point to a specific version of a piece of software. It can point to the general package of software, all the versions of the software, or it can point to the latest version of a piece of software. And one piece of software can have identifiers of all three types, and it also could have one or more software papers, each of them having identifiers. So we believe that the use cases we should be worried about are when somebody wants to cite a specific version, which is the most common thing that we think should happen, when somebody wants to cite the software in general, which also may happen. And we also then need to link multiple releases together so that we can understand all citations, so that somebody that has releasing different versions can understand how many citations they've gotten to their software product, not just how many citations they've gotten to all the different versions that might exist. The principles, as I said earlier, are intended to apply to all levels of software and also to all identifier types, such as DOIs or RRIDs or ARCs or whatever else there is. But we, again, recommend that whenever possible, we use DOIs that refer to specific versions of source code. There are different types of software as well that could be identified. The principles and the discussion up to this point have generally focused on software as source code. But some software is only available as an executable or a container or a service. And we intend that the principles should apply to all of these forms of software. The implementation will differ by software type. When software exists as both source code and another type, we are recommending that the source code is what should be cited. Access to software is also important. The accessibility principle says that software citation should permit and facilitate access to the software itself. The metadata should provide access information. For free software, for open source software, the metadata generally would include a UID that resolves to a URL that points then to a specific version of the software. For commercial software, the metadata should provide information on how to access that specific software, such as a company's product number or a URL to build the software, to buy the software. And you could imagine something similar for a container and executable that are distributed in a different way. If the software is not available now, it should still be cited along with information about how it was accessed. And the metadata of these citations, because this is attached to the identifier, should persist even when the software doesn't. The identifier itself then needs to resolve to something. And the first thing that a lot of people think about is having an identifier that points directly to the software, such as to a GitHub repository. And that would satisfy the unique identification, accessibility, and specificity principle, but it would not specify the persistence principle. We recommend that identifiers should resolve to a persistent landing page that contains metadata and links to the software itself, rather than directly to the source code. One way of thinking about this is that people in the past used a bunch of different repositories, including SourceForge and Google Code and a lot of other things that no longer exist. A lot of people today are using GitHub and Bitbucket and things that do exist, but there's no reason to assume that those are going to continue to exist as we go forward. It's reasonable to say that they probably will for some period of time, but it's reasonably likely to say that at some point in the future they won't again as well. And so we're trying to take advantage of the archival system that exists rather than using the repositories. And repositories are the right place to do work in software, and they're the right place to pick up software and to use it and to talk about it, but they're probably not the right place to archive it, and that's not what they're there for. So this is intended to ensure the longevity of the software metadata even beyond the software lifespan, and to be able to have archival versions of software that are kept in archival repositories. Things like Figshare and Zenodo are examples of archival repositories that accept software and give back DOIs, and GitHub, again, is not. So having gone through this discussion, I want to kind of say two examples of what you can do, and then we'll have another pause for more questions. The first example is if you want to make your software citable. And the answer of how to do this is to publish it. And if it's on GitHub, there is an easy guide that tells you how to do this. And if it's not on GitHub or you don't want to follow this guide, you can do effectively the same thing manually. Effectively, what you do is you tar the file, you submit it to Zenodo or Figshare or an institutional repository or something like that, along with the appropriate metadata, which includes the authors, the title, things that you have cited, and potentially dependencies. And you get back a DOI. And then you can create a citation file, and you can update your README, and you tell people how to cite your software. And you can also write a software paper and ask people to cite that as well. But again, we would say that that's secondary just because our current system doesn't work well enough right now. So the second example then is what to do if you're going to cite somebody else's software. And as you might guess, I would say that you should check for a citation file or a README. And if those things say how to cite the software itself, you should do that. If not, you should do your best to follow the principles. Try to include all contributors to the software in terms of the authors. And this is often very hard, and the workaround is often to name the project. Try to include a method for identification that's machine actionable, globally unique, interoperable. Maybe it's a URL to a release or a company product number. If there's a landing page that includes metadata, point to that and not directly to the software. But if you don't have an option, then pointing to the GitHub repository is probably the best you can do. In any case, include the specific version and release number. This could be a commit hash potentially, or something else. It could be a version number, it could be a release date. If there's a software paper, you can also cite that. But again, please don't do this in place of citing the software, just do this in addition. So again, I'm going to pause at this point and try to see if there are questions. And I see one from Max, who says, sometimes it's the case that when generating data for paper, I use a version of the software that's a development version and does not correspond to a particular number to release for the code. Is there any harm for creating a DOI to that specific commit? Can there be too many DOIs associated with a particular software repository? So I personally think the answer is no, that's a reasonable thing to do. As we go forward, I'll talk about some options that we have, but basically what I've talked about up to this point is what the Software Citation Working Group recommended. And there are some reasons that this may not be the right thing, but it's where things are now. So just to answer those particular questions, if it's your software, you can certainly create as many DOIs for particular commits as you want to. And if you're using the software and you want to reference it, that's, I think, a very good way of archiving the specific version that goes with that work. If it's somebody else's software, then you probably shouldn't be creating a DOI and archiving their software. And again, that's an issue that I can talk about as we go forward. But at this point, an easy thing would be to point to the GitHub repository and the commit hash and the version, if there is a version number that goes along with it. Can there be too many DOIs with a particular repository? In a theoretical sense, no. In a practical sense, yes, because the DOI system doesn't do a great job right now of tracking citations from one version to another. And if you want to get credit for what you're doing, you don't necessarily want that credit to be distributed over lots of different versions. You'd like to be able to pull it together into understanding how somebody is using your product. And I think that, again, will be fixed over time, but that's a little bit of where we are now. What about forked repositories? To me, that actually goes back to the question about when work builds on other work. So I would say you should cite the thing that you have forked, the thing that you're actually using. There are reasons people may not be happy with that, but I think that's the best answer that I can come up with at this point.
Hey, Dan, there was one more question that came in above Max's question. That's okay. I know it's hard to.
Oh, yeah, I see it. Yeah, no, it had just scrolled off my little window. So why should we expect DOIs? Why should we expect Figshare Zenodo to last? So in the case of Zenodo and Figshare, because I would say for two reasons. So one is that is the purpose of those organizations. They have come into being to be archival data repositories. And so it's not necessarily that they will last, but they were designed for that, and they have plans of how their data can be transitioned to other places if they do go out of business. Figshare is a commercial company. Zenodo is part of CERN at this point. They both have, I would say, reasonably strong institutions behind them. GitHub is a strong company, but GitHub, again, has not made any commitment to being archival and doesn't have any plan for what would happen to the data in GitHub if GitHub does go out of business. The other thing is that the DOI system itself also strongly considers this question of archive. And so there are mechanisms in DOIs and and agreements that people that sign up to mint DOIs come to about what their archival responsibilities are and what their transferring responsibilities are. So that's, I think, the answer that I would give for that. Okay, let me go on, and I'm happy for more questions to come in as well. And if I notice them, I'll stop and answer them, and if not, I will the next time we get to a break. So one of the problems that I was hinting at is software citation versus paper citation. There's 3 relevant steps when you want to cite a paper. The first one is that the creator, who we call the author, submits the paper to something that we call a publisher. There's potentially a review that happens, depending on if it's a preprint or a journal paper, potentially. And then that publisher actually does their publishing action, and they assign the paper an identifier, which is a DOI often. And then if somebody wants to refer to the paper within some other work, they cite the paper metadata that often includes the DOI. This is a fixed order, right? These things have to happen in this order, and they have to happen individually. For software today, the creator develops software on GitHub often, and they release it at different stages, different versions during its development. Somebody who uses the software likely is not going to cite it today, and if they do, they're often going to cite the repository. And so there's no step 2. There's no publication step that happens in open source. There's only a partial step 3 because there isn't often clear metadata or an identifier for the software that was actually used. The software citation principles insert step 2. This may not actually work in practice. And it may not work because it adds a step to the software developer's workflow, and the software developer may not care about credit enough to implement this step. And even if we get to some future time where developers routinely publish their software, what do we do until then? And what do we do for all the software that's been written up until this point? The real problem is that these steps of create and publish and cite don't really match how open source is developed and used. Software is much more fine-grained and interactive and iterative as well than papers are. And open source development happens in the open. And there's no natural need for this publish step other than marketing and credit, which aren't primary concerns in all projects. So if we think about this and go back to papers, we can think about what happens if the citer wants to refer to something that hasn't been published. Students initially are taught not to do this, and then at some point they realize that they have to in some cases, and they're told that they should call this a personal communication. The APA publication manual distinguishes between recoverable and unrecoverable data. And it says that recoverable data, which is that which can be accessed by the reader via the citation information, is what should be cited as a formal citation. And unrecoverable data should be referred to within the text by author, personal communication, and date. And the problem is that this distinction between recoverable, which is published and available, and unrecoverable, which is not published and not available, doesn't work for software. Because software can be not published but available. All versions of software on GitHub, even if they're never published, are recoverable by default or available by default, unless the project's deleted and it could still be recovered from a local copy. If we think about credit, the software citation principles say that it's not that academic software needs a separate credit system from that of academic papers, but that the need for credit for research software underscores the need to overhaul the system of credit for all research products. And the fact that this 3-step model of distinct creator, publisher, and citer doesn't really fit modern open source practices is another argument for that overhaul. So that's a problem. There are some possible answers here. One of them is called software heritage. Software Heritage is an organization whose mission is to collect, preserve, and to share all software that is publicly available in source code form. You can think of this kind of like archive.org or the Internet Archive, but for software. It stores source code in a Merkle tree with hash pointers. And if you wanted to cite something that was unpublished, you might imagine that you could find a hash that points to the version of it that's in this archive. And so we could get a tool that goes from a GitHub commit hash to a software heritage hash, and this could be developed. We also then would need an ID that goes with the software heritage hash, and this could be something like https://softwareheritage/ID. So this could be a compact way of referring to something in software heritage. And then this leads to a question about metadata, because this would be an identifier to the software, but it wouldn't tell you anything about the other metadata that you would want to cite it. So I think that there's two kinds of software metadata. Actually, I think there's a lot more than this, but for the purpose of this talk, let me limit it to two. One is software creation metadata. And this is things that talk about the properties of the software itself as source code, such as the authors, the language, the license, the version number, the location, etc. The second thing is software usage metadata. And this talks about how the software is being used, maybe including how it was built, things like compiler versions, operating systems, parallel computing platform, command line options, things like that. The software citation principles say that the software creation metadata is what's needed for citation. Software usage metadata is likely what's needed for provenance and reproducibility. And the metadata for provenance then is greater than the metadata for citation. It often includes the metadata for citation, but also the other metadata for usage. For code, a software user can determine software usage metadata, but they can't determine the software creation metadata. Only the software creator can determine that. Software heritage also can't provide the metadata that's needed for software citation. So if the software creation metadata can only be determined by the software creator, then what do we do? One thing that we can do is to use something called code meta. If authors of software want to be cited, they can actually say what their metadata is by creating a single metadata file in their repository root. As suggested by Martin Fenner, who's the technical director, I believe, of Datasight, work that's been done in code meta can be used. And so code meta is a project that has a goal of creating a minimal metadata schema for science software and code that's represented in JSON and XML. And an example of how this could be used is that in this repository that's on this line that's called Marima, sorry, I don't remember how it's pronounced. This repository has a code meta.json file in its root. And Datasight then, which is one of the organizations that actually generates DOIs, pulls that JSON file out, understands all of the metadata that's in it, and generates a DOI, and puts that metadata into the DOI system, and generates a citation that then could be used from that. And other repositories can do similar things. So the idea is that code developers would create a code meta.json file in their repository when they start a project, and then they would keep it up to date, just like they do their README or their contributors file. Software heritage keeps all versions of the code meta.json file because it keeps everything in the repository every time it changes, and it keeps them along with the corresponding versions of the software code. So anybody that wants to look at software heritage could go back and retrospectively build proper citation metadata for any version of the software, as long as this code meta.json file has been kept up to date by the developers. It's still not quite enough. The other thing is that authors may not care enough about credit, and they may not have created one of these files. And we also don't know how to cite older software, as I mentioned before. So most software creation metadata can be extracted from a repository directly, and some of you may already be thinking this, except the authors. So this is the one that we can't do, and this may be different than what some people are thinking. So I will argue that authors do not equal contributors to a repository. Some project contributors don't contribute to a repository. Examples of this are potentially a PI, somebody that's getting funding, people who are doing design of the software, people who are doing testing, people who are going out and giving tutorials. All of these people may be contributors who should be acknowledged as an author, but are not actually making commits into the repository. And on the other hand, some contributors to the repository should not be authors. I remember Neil Chu Hong from Edinburgh giving a talk at one point about 4 or 5 years ago for a software package that he was working on, where he had added a license file, actually license information to every file in the repository. And the repository said that he had contributed the most lines of code, which wasn't true, and what he had done actually, in the view of all the other developers, was not significant enough to make him an author. So the best thing to do if you can't identify the authors is to identify the project as the authors and to call it the something project, whatever the name of the software is. And if the authors aren't happy with that, they can certainly solve that and they can get credit for future versions as things move on. The other thing that's important is how we actually identify the software. Compact identifiers are a method for referring to a stored object in a registered repository. So as an example, if there's anybody who's familiar with the protein data bank, we have something that's called PDB:2GC4 that is a compact identifier to an accession or an item number in the protein data bank, and it's item number 2GC4, and I don't remember what this is, but it's something that apparently is meaningful to people that work in this community, and it's relatively compact and easy to put into a paper. We then have compact identifier meta-resolvers, identifiers.org and entity.net, which is name-to-thing.net, that can then resolve this compact identifier. And so you put it after one of these meta-resolvers, and it gives you then the landing page that goes with that object. So the compact identifier meta-resolvers could also work with software heritage to define compact identifiers for all the repositories that software heritage works with, and a means to resolve them to a pointer in the software heritage archive. And so this could be something like GitHub:/repository name/commit hash, which would be relatively easy for people to say it was the software that they used, and then we could build a system that actually could take that and go back into software heritage's archive and could point to something that is archival and will stay around. So with software heritage, code meta, and compact identifiers working together, I think we can get to a point where users can easily and effectively cite any archive software. So I'm going to actually stop at this point and then answer a couple more questions. I guess just one kind of from Sarat, then that's a couple of pieces. Given the choices, Zenodo, Figshare, et cetera, is DOE code recommended? And I don't believe that DOE code is intended to be an archive. I think it's intended to be a platform for work on code and for code to be distributed, but not for it to be archived. I'm not very sure of that. I have never used DOE code, and so if somebody else wants to disagree with me, I'd be very happy to hear that I'm wrong about that. I believe, though, the DOE code is effectively acting like GitHub, and it's acting like the social platform for development and for work, but it's not acting like the repository. And in terms of the follow-up question about metrics or indexing, again, I think that in terms of long-term indexing and long-term collection of metrics, we need to do things that are looking at archival versions of software. With the things I talked about in the last couple of slides, we may be able to do things better than that over time, but that's, I think, kind of where things are and what we need to use as the backing for the system. I don't know if Software Heritage has been talking with DOE code or not. If they haven't, I'm sure they will. So if DOE code is providing DOIs and metadata, then, okay, so then I'm probably wrong. So this probably would be equivalent to Zenodo or Figshare, and potentially maybe is even recommended by DOE for people that work for DOE. So honestly, the answer is that I don't know, and I would have to do more investigation. But I hope what I've given you is an idea of principles that you could use also to make a decision. So any other questions before I go on to the next piece? Okay, so let me go on a little bit more. This is kind of basically the state of where we are today, and I want to talk about kind of where we actually are. So this is a graph of the number of DOIs for software that have been registered at Datasight. It's about 50,000 total, and this started in about 2012, and it goes up to a couple of months ago. This is not completely up to date, but it's pretty recent. If I look at this by eye, I see kind of 3 different periods, maybe 4 different periods that I can identify where there are changes of slope. And I want to point out some of the things that happened here that I think maybe are responsible for these changes. And so one thing that I want to point out is that NanoHub, which is built on Hub 0, was the first large-scale activity that started issuing DOIs for software. And NanoHub had a bunch of software that had been built, and it intended, at some point around the beginning of 2013, went through all the things that were there and issued a bunch of DOIs for them. And so that's that spike. At the kind of midway, early 2014, the Zenodo GitHub integration was introduced and advertised, and it's worth also mentioning that 90% of the DOIs that are registered now have come through Zenodo. Figshare started putting DOIs, started accepting software and giving out DOIs in 2016, and this is a burst that came out in that time. The software citation principles and preprint was kind of late 2016, and so I think that that's responsible again for a change of slope. And then of these other spikes, we know one of them is coming from the Bioconductor project, which I don't know much about, and we have not yet identified where the other spikes are coming from, but we're kind of interested in seeing this. So I think that the message here is that software DOIs are growing. They're growing in some cases for reasons that we can explain, in some cases for reasons that we can't completely explain yet. Another thing to talk about just very briefly is the Journal of Open Source Software. I've talked so far about how everything that is software should be cited directly, but I also want to say that there's something else for people that don't want to go fully down this path yet. That's the Journal of Open Source Software. It's a developer-friendly journal for research software packages. I'm one of the founding editors, which is why I'm bringing this up. What we say is that if you've already licensed your code and have good documentation, we expect it should take less than an hour to prepare and submit your paper to JOS. Everything about this is open. The submitted and published paper is open. The code itself is open, although what repository you're using is up to the authors, whether it's GitHub or DOE code or something else. The reviews in the process are open, so there's nothing anonymous here. Every review is an issue in GitHub, and anybody can see that issue and see where it is. Code for the journal itself is also available. So if you like the idea of the Journal of Open Source Software and you want to spin off something else, you can take our code and create your Journal of Open whatever you want. There's a Journal of Open Scientific Education that has started, or maybe it's Open Source Education, Jose, and that one's kind of spinning up now. I don't think it's completely active, but if you look at the GitHub repository, you can see that it's in the process of getting going. JOS papers are given DOIs. First paper was submitted in May of 2016. After about a year, we had 111 accepted papers. A little while ago, earlier this month, we had 258. I think the number that I saw yesterday was 267. So this is continuing to go up. We're not going to get to 300 by the anniversary, but we'll get fairly close, probably around 275. So, so this is something that is picking up, and a lot of developers seem to be very happy with, because it's fairly easy, and they also are happy with the ability to be able to review other people's papers and to be able to help other people with their software. So this is a very collaborative process. It is not an adversarial process at all. The working group, the Force 11 Citation Working Group, again, we published our principles document a couple of years ago, and then the group ended. We then started a software citation implementation group, which is now in process, and our goal is to actually take the principles and implement them. And this is one of the reasons I'm giving this talk as part of this. We're interested in working with institutions, publishers, funders, researchers, and anyone else relevant to this process. We're planning subgroups to study a bunch of use cases, pretending that they have different roles. I shouldn't say pretending, I should say exploring the role, how different roles work. And each group that then would try out a different role would find and advertise the gaps and would suggest and try solutions. We've had some discussion of joining with the Research Data Alliance Software Interest Group. I think we're going to end up having a joint group that will spin off that will be looking at software identifiers specifically, and overall we will not merge completely. And if you're interested in joining what we're doing, you can sign up on the Force 11 group page. Again, the slides will be available after this. Some examples of things that are happening. So one is the Datasight, which again is one of the entities that issues DOIs, has been extending their schema. And in the latest version of the metadata schema they have, version 4.1, which I'm pointing to the schema and a blog about it, they are now adding support for software citation intended to facilitate software discovery, sharing, and citation. And what they've done in their schema is to add two new relation types, has version of and is version of, sorry. Excuse me, has version and is version of is one type, which relates versions of the same software, such as the master repository, maybe that describes the software package itself with a bunch of the different versions that are released, and is required by and requires, which could be used to identify software dependencies, again, within the metadata for the DOIs. They've also put in a bunch of additions and modifications to their documentation to clarify the use of software citation. Another is community-specific implementations. I've been working with high energy physics people, in particular the ACAT conference last fall and the CHEP conference coming up this summer. So the preceding authors will be able to cite citation, and software developers then would make their software citable. There's a short paper that I wrote about this from ACAT, which you can, again, pull up afterwards. And we could generalize this for other conferences and other communities. In astronomy, there's a bunch of work going on now in terms of handling software citation between the main publisher, AAS, the main indexer, ADS, and software repositories and Nodo specifically. And this is being attempted to be implemented in the next couple of months, but this model is generic and could be done in other disciplines where there is a clear publisher and indexer and repositories. Clearly, this is a generic repository, but the fact that there's this nice pairing and relationship between the publisher and the indexer and the community makes this easier to try in astronomy than it might be in other places. And then third, in the geosciences, in the AGU community in particular, there's a related effort focusing on data called Enabling Fair Data, and this effort is also starting to consider software. And I'm just including a link for people that want to get more information about that. So these are 3 different community activities that are going on, trying to move software citation into more common practice. I'm working on these 3 activities under a fellowship from the Better Scientific Software Project activity. BSSW is in some senses a website, in some sense it's a community. It has this slogan, "So your code will see the future." Sorry, now I'm advertising for OSNI for one slide. BSSW, again, is supporting what I've been doing via fellowship. My goal overall is to make scientific software more sustainable by providing credit to its developers via software citation and working with disciplinary communities. And if you want more information about what I'm doing, or you want to see a copy of the fellowship application that I put in, they're both available on this blog. There will be a new call for fellows next fall. Probably next fall, probably towards the end of the year. And my guess is that new fellows will be announced likely at the ECP meeting next spring. So another thing that's going on is actually using code meta.json. So the Caltech data, which is Caltech's research repository in their software preservation activity, they take GitHub software repositories and bring them into their system and give them DOIs. Probably this is similar to what DOE Code is doing. They recently extended their work to use code meta.json files when they exist, so that if an author has put one of these files into their repository, that's used to pull out the metadata that's in the Caltech data repository's DOI that it gives out and in its archive. And there's a little article that they wrote about how they're doing that. Datasight also is building a new DOI registration web service that gives DOIs for repositories, not for specific versions of software. And so the idea here is that you could provide a GitHub URL to a service, and that would then register a DOI for that software package and would automatically populate the metadata file if there's a code meta.json file. And if there isn't, it would give an error and would actually then require the people that wanted to get the DOI for their package to build one of these files. So again, these are things that are going on. There's also a need to coordinate with something called the citation file format, which has as its goal having human and machine readable citations. This is related to, but not the same as code meta.json, and we are working to bring these 2 things together. So to wrap up, I hope that I've made the case that software is important today and will be essential tomorrow. In terms of credit, this is a known problem for papers, but it's much worse for software. Citations, we know what to do, more or less. There's a few details where we don't exactly, but we're working on it. But we actually just need to start really doing it. This is explained in a website called cite.research-software.org. This is kind of an easy way to start looking at some of these issues. And what we need to do now is to build support for using code meta.json in our repositories, to build up tools around software heritage, and things like that. And so what you can do as listeners to this webinar or the video, I guess, that's coming after it, is to cite the software that you use, to make it easy for other people to cite the software that you write by making it citable. And if you're interested in a few more things, there's a manifesto called I Solemnly Pledge that includes these 2, along with maybe 7 more things. That's a nice little paper that we wrote at a Dogsteel workshop about 2 years ago. So with that, the other thing that you can do is when you're organizing meetings, when you're editing, when you're reviewing, please take software citation into account. Right? If you're reviewing a paper and you can see that there's software in it, but it's not cited, comment in your review that the software should be cited, things like that. So finally, give thanks to a few people. Arvind Smith and Kyle Niemeyer were my co-chairs in the Force 11 Software Citation Working Group and co-authors on pulling together that paper. Neil Chu Hong and Martin Fenner are my co-chairs in the Force 11 Software Citation Implementation Working Group, and we're the folks that are trying to push this forward now. I should thank the BSSW project, which with the typo ignored, for giving me the fellowship that's allowing me to pursue some parts of this. And if you're interested in more about what I've been thinking on this, I have a blog, and I also tweet fairly often. I think one of the blogs also has been cross-posted on the BSSW site. So with that, I will stop. Thanks very much for paying attention, and I will try to look at some of these questions briefly that have come through. So just kind of scrolling through things, discussion about DOE code FAQ. Right, so I think it looks like this then does say that that for people that are working in DOE, that they potentially should be using the DOE code site as opposed to Zenodo or Figshare. For people that aren't, I think it's up to you, and I honestly am not going to say what DOE's policy is because I don't know what DOE's policy is, but if this is a specific thing that you should be using, then you should use it. Okay, and then the last thing that's on here on chat from Sarat, principle of specificity leads to perhaps citing specific versions, but it's difficult to aggregate credit across versions. You mentioned some efforts to address this. Can I elaborate? So no, I can't, unfortunately. We don't have a good answer to this today. This is part of what the Software Citation Implementation Group is working with. And we're trying to work with some of the groups that actually generate some of these repositories, like ideally like Google Scholar or Web of Science. I don't have anything specific to report right now other than that this is something that is an issue that we're talking about and trying to work through. For Graham, in the area of citation, what's the best practice for software authors today? So I would say the best practice today is to release major versions through a repository, get DOIs for those major versions, provide metadata in a code meta.json file, keep that up to date, and to use the DOIs that come out from those major versions in your README and in your citation file in your repository, and to ask people to cite those. I think if you want to be kind of a bit safer, having a software paper today is probably also a good thing because it's going to fit better into the system while we are working on these other things. And so I honestly can't say that having a software paper is a bad idea. It's a question of how much work you want to put into it and what value you get out of it. The JOS model, I think, is a relatively small amount of work for a relatively large amount of value. Full papers are much more work, slightly more value. It's really up to the authors to decide what they think the best thing is to do. I don't think that there's any one answer, unfortunately. Okay, so if there are other questions, people, I guess, can feel free to unmute and ask or type.
Okay, thank you very much, Dan. I don't know if people have other questions.